Hello students, in the given question we have been provided that three electrolytic cells A, B, C containing solution of zinc sulfate, silver nitrate and copper sulfate respectively are connected in series. A steady current of 1.5 amperes was passed through them until 1.45 gram of silver was deposited at the cathode of the cell B. Now we have been asked how long did the current flow, and second thing we have been asked what mass of copper and zinc were deposited. Okay, so first of all, as we can see, all the three salts are connected in series. Okay, since of them are connected in series, that means current will be same throughout all the cells. Okay, series means current is same. Okay, that is the meaning of series. Now, if we know what is the Faraday's second law. Okay, Faraday's second law of electrolysis. Okay, Faraday's second law of electrolysis state that if we pass same amount of electricity through given salt solution, okay, what it states that if we pass same quantity of through electricity through several electrolytes, the mass of the substances deposited are proportional to their equivalent weight. Now this means that if now we have three salts, okay, and the at cathode there is reduction. Okay, at cathode what happens is reduction. Okay, and what are the three cations that are gonna get reduced? First is our silver cation. Okay, Ag will get reduced to Ag metal. Okay, similarly our copper cation will get reduced to copper solid. And finally, zinc cation will get reduced to zinc salt. Okay, so as we know, first of all, we can write the equivalent weight. Equivalent weight is equals to molecular weight upon n factor. Okay, that is the value of equivalent weight. So, as we can see in the given question, we have been provided that silver's mass deposited was 1.45 gram. Okay, so that means since we are passing same electricity to all the three electrolytes, that means their equivalent weight upon the amount of metal deposited, amount of metal deposited will be a constant value. Okay, so we can write the relation and find the mass of zinc as well as copper deposited using this equation. So we know equivalent weight of silver is 108, its molecular weight upon n factor, as we can see 1. So 108 upon 1.45, that is the amount of silver deposited provided to us in the given question. And first we can find for copper. Okay, so let us assume that the amount of copper deposited is X copper. Okay, we can refer it as XCU. And copper's molecular weight, as we all know, is 63.5. Okay, and its N factor from the reaction, as we can see, 2. So when we can write this as 63.5 upon 2. So X 63.5, 2 will get in the denominator. We can get the amount of copper deposited, which is XCU. I'm referring it as XCU. It will come out to be 0.426 gram. Okay, so this is our amount of copper deposited on cathode. Okay, because at cathode reduction occurs, so copper will be deposited at cathode. Now similarly, we can find for zinc. So just use the equivalent weight of zinc. So equivalent weight of zinc will be equals to its molecular weight, that is 65.3. Okay, upon, as we can see, the n factor of zinc is 2. Okay, the valency or the number of electrons are 2, so n factor is 2. Now we can write it equals to 108 upon 1.45. This time our x will be x zinc, up in the numerator will be molecular mass of zinc upon 2. Hence this is the equivalent weight. When we do the calculation, we will get the amount of zinc deposited to be equal to 0.438 gram. Okay, so these are our two answers. see, first we have calculated the amount of copper that comes out to be 0.426 gram. Then amount of zinc that comes out to be 0.438 gram. Now, the one question that is also being asked, that what is the, how long did the current flow? Okay, we now have calculated mass of copper deposited and mass of zinc deposited. The only thing left that is to find what is the amount or duration of current flow. Now we know that what is current. Current is given by Q upon T. Okay, this is the value of current. Now, as we can see, in the given question, we have been provided that 1.45 gram of silver was deposited. Okay, 1.45 gram of silver was deposited if the amount of electricity, as we can see, is provided to us as 1.5 ampere. Okay, now how much amount of silver is deposited? 1.45 gram of silver was deposited if I equals to 1.5 ampere. Okay, now as we can see from the reaction, okay, as we can see from the reaction, to deposited 108 gram, to deposit 108 gram of silver, we require 1 mole of electron, and 1 mole of electron has 96500 charge. Okay, as we can see, 108 gram require 96500 coulomb. Okay, so to deposit 1.45 gram, the amount of charge in coulomb will be 96500 into 1.45 upon 108. Okay, so we have calculated the charge with the help of this. Okay, the charge will come out to be 1295.6 coulomb. Now we know the basic formula that Q equals Q upon T is I. We have the value of current to be 1.5 ampere. Okay, this is 1.5 ampere. So we can calculate the value of Q. We can calculate the value of time. So Q upon T is I. So we have the value of Q as 1295.6 coulomb. Okay, and our I is 1.5. So time will come out in second, and it will be nearly equal to 864 second. So we have calculated the time of current, okay, current duration, and we have also calculated the mass of zinc deposited as well as mass of copper deposited at cathode. So these are our answer for the given question.